Standard rays converging lens. Ray incident parallel to the principal axis pass through the principal focus after the refraction, as you can see from the drawing here. So the first line is the red, which is called the ray, the first ray, and the blue one is second ray. They both pass through the principal focus, the green dot. The arrow is used to see where did the light go. Where did the rays passing through the center of the lens are not deviated. As you can see, there are two lines, which is red and blue. They all went to the center of the lens, as you can see from the middle of the lens. Standard rays converging lens. Rays passing through the principal focus before refraction are reflected parallel to the principal axis. The first ray, which is the red one, start from the first focus point, and pass through the lens. The second ray is the blue one, which pass from the second focus and pass through the lens. Converging lens images. Object more than twice the focal length distant from a converging lens. Here are the diagrams. Just an example, the object is 2 centimeters, and as you can see, there are 3 lines there. And the first line is the top one, is just go directly focused and then bend it down to the focus line, to the focus points. The second line is directly go to the just like middle straight. And the third one is focus, go to the focus, and then parallel to the principal axis. In there you can see the image, like the point where the image can be seen. The uses of this is camera and eye. The image form is smaller than the object, which is diminished between the f and 2f. It is inverted, which means upside down, and it is real. Light rays travel to the image. Converging lens images. The object between f and 2f. Here are the diagrams, as you can see, and the principle for the 3 lines is still the same as before, the first one. And the object, as you can see, the length is much smaller than the image. Angle of incidence equals angles of refraction. In other words of the statement, if light gets reflected from a surface and hits back with the same angle. So, as you can see the line, and there the angle of incidence. The angle of incidence, let's just say, for example, 45. And when it's bounced back from the surface, it is called angle of refraction, which is the same angle. It is also 45 degrees. Why is angle of incidence is equal to angle of refraction? Angle of incidence is equal to angle of refraction when the light rays hit the surface. As I said before, light is also refracted while incident interface between 2 different materials, such as the surface between air and water or glass and water.
The image in a plane mirror is always virtual. It is also laterally inverted. The word ambulance is laterally inverted so that it reads correctly when seen from a driving mirror. Also, the image is formed upright, but it is a virtual image, which means that it's not real. So, for example, a truck moves along the road with a steady speed. This is because the tires have a good friction against the road. Okay, so it's about to pass through sand, and because the truck isn't moving perfectly forward, one tire will pass through the sand first, then the others. So obviously, the 2 tires on the other side will still move at the same pace, while the first tire on the sand will start to slow down as it is harder to move on sand. When this happens, one side of the truck will slow down and the opposite side will be faster. This will cause a turn, resulting in a change of direction. And this way is similar to the refraction of light.
So Once you've done that, you will then need to, using a protractor, create your normal lines. Normal lines are at 90 degrees to the surface of the block. So you can see that. Oops. So mark a point on that. 90 degrees there, and I'll just put my dashed normal line. So, and then I'm going to shine in my light. I'll put my block back over there, and I'm going to shine in my light. Okay, now you can see, I'll switch the lights off. You can see the light ray clearly, so I'm going to put 2 dots here, following the path of the light ray, and 2 dots as it exits. Okay. Now I can get rid of the block. Okay, remember this is shined in, the light ray is shined in on the junction between the normal line and the edge of the block. Next, you need to join up your light ray. Always drawing an arrow. Join it up at this side, and then join up your 2 light rays there. Okay, then you can measure using your protractor the angle of incidence and the angle of refraction. So my angle of incidence is looking about 47 degrees. My angle of refraction is about 27 degrees. Okay, and that's how you'll determine your refractive index once you've got the values for angle of incidence and the angle of refraction. You'll need to do that about 3 times to make sure you've got enough results so that you can be sure that your reflective index is consistent. Okay, so you want to shine it in maybe at 3 different angles, maybe one like that, maybe one like that, and maybe one like that, always following the path of the incoming ray and the outgoing ray.
The critical angle is the angle of incidence for which the refracted ray is at 90 degrees with the normal. Occurs when the incident angle is equal to or less than the critical angle, where some of the light ray will be internally reflected and some refracted. Phenomenon that is observed is called total internal reflection. It occurs when the incident angle is always greater than the critical angle, where all the light ray will be internally reflected.
The refractive index of a medium is indicated by the symbol of n, and is defined as the ratio of the speed of light in a vacuum over to the speed of light in a medium. The amount of transparent medium decreases the speed of light. Here are the formula is n equals to c over v. The example is, the index of refraction of its diamond is 2.4. What is the speed of light in a diamond if its speed in a vacuum is 3.00 times 10 to the power of 8? So the n is 2.4 and the c is 3.00 times 10 to the power of 8, and 2.4 equals to 3.00 times 10 to the power of 8. The result is 125,000,000.
So what is n equals sin I over sin r? Well, refractive index equals to sin multiplied by the angle of incidence, or so-called as I, over sin multiplied by the angle of refraction, which is r. Refractive index is the measurement of the speed at which light passes through a substance relative to the speed of light in a vacuum. It also indicates how much light will be bent when it passes from one substance to another. Okay, let's take an example. A beam of light hits a glass block, and the angle of incidence is 55 degrees, whereas the angle of refraction inside the block is 33 degrees. Let's calculate the refractive index. So we can see from the picture that the incident ray comes in the glass block with 55 degrees from the normal line, whereas the refracted ray goes 33 degrees away from the normal line inside the glass block. So there are three steps we should do to find out the refractive index. The first step is to work out the sine of angle I. Sine 55 equals to